Hi, my name is Eric, and today I'll be reviewing with you how to go about solving the law of sines. So the law of sines is defined as the relationship between the sides and angles of oblique, i.e. non-right triangles. It states that the ratio of the length of a side of a triangle to the sine of the angle opposite that side is the same for all sides and angles in the given triangle. And this is represented by the formula side of A over sine of angle A equates to side B over sine of angle B, which equates to side C over sine of angle C. Now, when using the law of sines, you typically have three variations of given information, which are the angle-angle sine, in which you're given two angles and a side that corresponds to one of the given angles, the angle-side angle, in which you're given two angles and a side that doesn't correspond with either one of the given two angles, and the side-side angle, in which you're given two sides and an angle that corresponds with one of the given sides. Now, when solving the first two, the angle-angle side and the angle-side angle, you solve the triangles by using the law of sines. However, when solving for side-side angle, you have to take into account the ambiguous case, which states that if two sides and an angle opposite one of them is given, i.e. the side-side angle, three possibilities can occur. The first such possibility is that no such triangle exists, and the conditions for this are that if angle A is acute and the side of A is less than the height of the figure, or that angle A is obtuse and that the side of A is less than or equal to the side of B. The second possibility is that two different triangles would exist, and the conditions for that are that A is acute and that the side of B is greater than the side of A, which is greater than the height of the figure, and in every other case only one triangle will exist. Now let's look at a few examples. Example 1. Given that the angle A is 30 degrees, the angle B is 20 degrees, and the side of A is 45, solve the triangle. So we're given two angles and a side that corresponds with one of the given angles. So we can verify this as an angle-angle side. And we can solve for the triangle by using the law of sines. For example, when solving for side of B, we took 45, which was the length of sine A, over the sine of angle A, which was 30, and equated it with our unknown side of B values, which we represented by B, over the sine of angle B, which was 20. So we cross multiplied and we isolated the B, which was 45 by sine of 20 over sine of 30. So the side of B was 30.78. And you could figure out the side of C in the same manner, and you figured out the angle that was left out by simply adding these two angles together and subtracting them from 180. Example 2. Given side of A is 15, side of B is 25, and angle A as 80 degrees. So we're given two sides and an angle that corresponds with one of the given sides. So we can verify this as a side-side angle. And when solving side-side angles, we have to take into account all possibilities of the ambiguous case. So we're going to test each possibility until we find the circumstances that correspond to our given information. So for possibility 1, the circumstances are that A has to be acute and that the side of A has to be less than the height of the figure, or that angle A is obtuse and that side of A is less than or equal to the side of B. So our given angle A is 80 degrees, which is acute, which meets the first of the criteria. And we determine the height of the figure by multiplying the side of B by the sine of angle A, which in this case was 24.62. A was 15, so we can conclude that H is greater than A, and since it meets both conditions, we can conclude that this triangle does not exist. Example 3. We're given that the side of A equates to 6, the side of B equates to 7, and that angle A equates to 30. So we're given two sides and an angle that corresponds with one of the given sides. So we can verify this as a side-side angle, and like we did previously, we're going to analyze each possibility until we find our which one corresponds with the given information. So, for possibility 1, our given A is 30 degrees, which is acute. H in this case was 3.5, and the side of A is 6. 6 is greater than 3.5, so therefore A is greater than H, which does not meet the criteria given for possibility 1, and as a consequence we can absolve possibility 1. Possibility 2 states that for two triangles to exist, A has to be acute and that B, the side of B has to be greater than A, which has to be greater than H. B is 7, or side of B is 7, side of A is 6, and the height of the figure is 3.5. 7 is greater than 6, which is greater than 3.5. So therefore, we can conclude that B is greater than A, which is greater than H, which meets the two given criteria for this, so we can verify this as possibility 2. And since we have two triangles, on note, one of the triangles is going to have an acute angle B value, and the other triangle is going to have an obtuse angle B value. And you go about finding these two respective angle B values by this. You find the acute angle B value by using the law of sines as shown previously to find the angle value. So, in this case, the acute angle B value was 35.69, and we take that acute angle B value and subtract it from 180 to get the obtuse angle B value, which in this case was 144.31 degrees. So our final example, given that the side of A is 22, that the side of B is 12, and that angle A equates to 40 degrees. So we're given two sides and an angle that corresponds with one of the given sides. So we verify this as a side-side angle. So for possibility 1, angle A is 40 degrees, which is acute, which meets the first of the criterion. We found that the height of the figure equates to 7.713, and that the side of A is 22. 22 is greater than 7.713, i.e. A is greater than H, and as a consequence, we have absolved possibility 1. For possibility 2, A is 40 degrees, so it's acute, which meets the first of the criterion. However, side of A is 22, whereas the side of B is 12. So therefore, the side of A is greater than the side of B, which does not meet the criterion for possibility 2. And as a consequence, we have absolved this possibility, and by default of absolving both possibilities 1 and 2, we have to conclude that the triangle is possibility 3, in which only one triangle exists, and the said triangle is solved by using the law of sines as shown previously. In summary, we have reviewed the application of the law of sines, given information for variations, angle, angle, side, angle, and side angle, and we have also discussed how to handle the ambiguous case for the side angle. I hope this lecture has helped you, and best of luck on your future mathematical endeavors, and thank you.